phone was open, so we muted everyone. Well, it's my enormous pleasure to welcome you to the University of Birmingham, those of you who are here physically, and to our facilities, those of you who are joining online, and to introduce Dr. Nigel G Harris. I lead some training in planning and systems engineering here. Nigel helps us out with some guest lectures, as he does other universities around the place. So I know firsthand that he is a systems thinker, a relentless observer of the railways and thinker about the railways. Time spent with Nigel is never a waste of time. And as someone with a planning background, he does, of course, start the V-life cycle. In transportation, the top left isn't done by systems engineers, it's done by transport planners. So Nigel's going to give us a perspective from that point of view. Nigel.
Well, good evening, everybody. I'm never quite sure what happens when you're going to be introduced and what people are going to say. So there's perhaps a few other things I should say about myself. I'm going to start off, as Bruce has hinted, with an apology. I'm not a systems engineer. In fact, even worse, I'm not an engineer at all. But I hope that some of the things I will say to you this evening will generate some discussion as to the sort of issues that I've seen. I'm very lucky. I've worked all over the world and for nearly all of Britain's train companies. So with apologies to our US audience, I'm not going to say a great deal about America. Various other places will be mentioned, but hopefully the lessons and thoughts are helpful. So let's try that. I'd like to divide this session into 5. I'd like to say a bit at the beginning about wider planning processes, and then specifically say something about timetabling processes as a part of that. Then I think we can learn quite a lot from where things have gone wrong. And maybe from that, we can start asking ourselves what we should know in terms of planners and engineers. I hesitate to say I have any conclusions, but hopefully with some discussion, we might between us come to some conclusions. So, some years ago, I found this postcard. And it very much resonated with me because I've just moved, but I've lived for about 30 years in London. And there did seem to be a phase where the mayors of London seemed to initiate railway projects by joining together the ends of lines on a map that were all, the lines that were already there. This specifically happened in relation to an proposed extension of the Croydon tram link. So it met up with the London Overground, and I'm going, but why? And then I was amused by this postcard, particularly by the child on a tricycle who appears to be drawing 3 parallel railway lines. And before you think that's stupid, we did in Nottinghamshire in Britain in the 1800s have 3 parallel railway lines 50 metres apart. So people have done that, and perhaps that's actually not best practice. 7 or 8 years ago, I was asked to set out what might be a diagram to say something about the railway planning process, and I put this together. And as Bruce hinted, I kind of have to start right at the beginning. I don't think you can do much railway planning at all unless you've some policy. What do I mean by that? Well, for example, let's not talk about trains for a minute. Let's talk about aeroplanes. Are you going to be a low-cost airline or a full-service airline? That's the kind of decision that comes at the top. Because if you don't make that decision, you buy the wrong planes or trains. So there's a whole load of stuff well before you've kind of started. We haven't even thought of engineers at this stage. Once you've decided whether you're going to be a metro or run sleeper trains or somewhere in between, then perhaps we get into some technology issues. This is where engineers get excited. Are we going to electrify things or have multiple units? Or that's fine. But about this stage in the process, I witness some different strands of activity coming along. And you see them in this diagram. On the left-hand side, there's what I would call the sort of demand planning thing, where we try and work out how much traffic we might get. Then there's a sort of route planning thing where we see if there's actually somewhere physically we could put things. Then we might have some trains. And then we might think about people. And there's a whole lot of other stuff. And my contention is that in a badly run railway, we do all of those things on their own. In a well-run railway, we also do all of those things, but in a well-run railway, we don't just have the blue downward lines that I've drawn in this diagram, we have some of the red ones. So, for example, it is helpful if you're building a station to know how long the trains are going to be, although those of you who've been in the railway will all have seen schemes where we haven't done that. And also, if you wish to write a railway timetable, it's generally helpful to know how fast the trains go and how fast X. Yes, but we've also tried doing it without that. So the red lines, in my experience, are the difference between a well-run railway and a not very run railway. And the bizarre thing is the diagrams are really very similar. And in both cases, we hope to come to some conclusions at the end and do something. But maybe those differences are a bit subtle for people. Not you, not this audience. This is an audience of people who think, but maybe problems for elsewhere. So what do we do in railway planning? Well, we kind of, I think the purpose of railway planning is to think about and test the sort of costs and benefits you might have with doing a thing. And we can formalize that into some form of ratio. But it's necessarily iterative. And I think that's the first mistake that external people get. They think you can jump straight to your conclusion. We had one railway timetable in Britain that I'm aware of, which got to iteration 85. So we need to go round. And look, there's no point in spending a lot of time and money at the beginning examining lots of detail if that option doesn't happen. So that's fine. Network Rail in Britain had these GRIP stages, governance for rail projects. And in my simple understanding, GRIP stage 1 with some ideas on the back of an envelope. And you work these up into more detail. And by the time you got to GRIP stage 5, you'd actually worked out how many bricks you needed for this viaduct. And then someone went and built it. And you did some stuff. And GRIP 8 was closeout. But in Britain, GRIP got a very bad reputation. It seemed to drag on. So we sort of replaced it about 5 years ago with the government having these decisions. And I can never remember what they are. I have to remind myself at the screen. So we do some stuff. And then, is this looking promising? We'll now have a decision to take further, a decision to develop. So we develop a bit more. We have another gateway. Are we actually now going to design this in detail? And eventually we're going to have a design to deliver and then accept something. But I see the same problem with this as with GRIP. There's no incentive not to do too much work. Because if I come to Bruce with a one piece of A4 paper, so there you are, that's what I'd like to do, people inevitably ask questions, which is great. Now, Bruce is a nice bloke, I'm not worried about his questions, but you will all walk for people where the questions are a bit kind of hard work. And the way you prepare for that is you do more homework beforehand. So we work out, if you're not careful in the very first decision, whether it's actually going to be 3 or 4 bats we need to move in this disused tunnel. We don't really need to know that till design stage 3, but I think the first problem we have is being rigorous. Lots of people that I know don't get the idea of establishing something in principle. In principle, is it a good idea to build a metro in this city? Or, what does it depend? Is the city roughly the right size? And I think that's something we should think about. I think we sort of want to go into more detail because people are not sure enough of themselves, I guess. So I thought we'd go through some objectives. Now, one of my favourite questions of anywhere in the railway when I'm a consultant is asking people the following question. So people come to me and they say, Nigel, I've got a problem here. I go, okay, what are you trying to do? Now that often completely gets rid of them, but I thought we'd look at some potential objectives for railways because actually it's quite a range. You could, of course, some schemes do, they're about making money. That's a very clear objective, quite helpfully clear actually. Many of you will be familiar with the concepts of generalized cost in terms of we're looking at the hassle of travel. Can we minimize access time and waiting time and in-vehicle time and interchange and fares and so on? And could we get traffic from doing that? Well, you have to be slightly careful, I think, with your objectives. So I thought I'd start off this point by showing a picture of Dadar station in Mumbai in India. Because, for example, if you want to maximize the traffic on a railway, well, there's some interesting decisions you should take. I mean, clearly, it's fine if people travel on the roof. And by the way, you see there are a couple. It is overhead electrified, but there were people traveling on the roof. And also, if you want to maximize traffic, you shouldn't have doors in a train because you can fit more people in if some of them are sort of in the doorway. So actually, you might have thought that was a very sensible objective, but we put some constraints on it, don't we? We perhaps don't want to maximize traffic because this thing called safety comes along. We'll come back to that. Or we might be something to do with road congestion and doing something about travel time. So in Britain, most railway schemes are really largely driven, most transport schemes, by saving people's time. And we've been doing that for most of my life. But over the last few years, one or two people have had some second thoughts. So at University College London, we've got Professor David Metz. He's been doing some very interesting analysis, which shows all sorts of things. In my lifetime in Britain, so we have something called the National Travel Survey, which reports every few years. What you can see is that people in Britain make pretty much the same number of trips they did per year as when I was born. When you make them, enable them to make those trips more quickly, what they do instead is they travel further. So actually, hang on, if we're going to save people time and all they're going to do is spend it on more time, really? And if that's, you know, one of David Metz's things, all this effort on saving time, maybe not. Maybe we don't want everyone to travel huge distances. For example, if you're a green economist, you'd probably prefer that people did their shopping at the end of the street they live in and not in a city 100 miles away. With respect to our friends from America, I was horrified a couple of years ago when I discovered that some neighbours of my parents who live in northeast England, they went to New York to do their Christmas shopping. Now, I've been to New York, and New York's a lovely place, but actually, if you want to buy things, there are actually places you can buy things in Britain. I mean, London, for example, or Birmingham. So I'm sure they enjoyed the treat, but they weren't really saving any time, were they? And of course, we have a problem with road traffic congestion. And this is something where I think politicians and the general public have not kept up with academic thinking. And I'm going to quote a date here, which is probably even before Bruce was around, as well as me. Wardrop noted in 1952 that it wasn't actually worth getting rid of road traffic congestion by building more roads. If you want to get rid of road traffic congestion, the thing to do is to improve public transport. And you can prove that as the average speed of public transport goes up, it leads to a speed increase in road traffic because it's an equilibrium. So we've known this for that long. Yes, that doesn't seem to really got into mainstream thinking, does it? But you can go and see the analysis yourself. So maybe that's not the right objective either. Oh well, let's get back to my list. You might also build a railway for maximising social benefits or employment. So, for example, in Britain, we generally lost our coal industry in my lifetime, and we deliberately reopened railways, Wales is a good example, from coal mining areas to give people access to jobs in the city, like Cardiff or Leeds. It's fine. We've built railways for Military access. I mean, that's why the Trans-Siberian Railway was built a long time ago. It's, I don't think they'd admit it. I think if you ask Australians why they built the railway from Adelaide to Alice Springs to Darwin, there's a bit of that in there too. We'd look at environmental things, although the rate at which cars are getting more environmentally friendly in Britain, we're not electrifying our railways, maybe we're losing some of that benefit. And then this picture is about economic activity. So you can build a railway to help economic activity, either at the local level, but I wanted to share this example from the national level because it's the best example I've ever come across. It's from Ethiopia. So in 1910, the Italians built a narrow gauge railway from Djibouti to Addis Ababa. And as you can see, when they got to a sand dune, they generally went round it because it kept the money down, kept the cost down. After 100 years, however, this railway was, I think the technical term is sad, and clearly there was some road competition. And the Ethiopians have had a railway built for them by the Chinese, a standard gauge railway. And the business case was just unbelievable, really. If you buy a thing in Britain, I mean anything, table, typically 4 or 5% of the cost is transport. Now you need to know a bit about the geography about Ethiopia. It's quite big. Addis Ababa in the middle, a long way from the sea. And like most countries, they don't make anything themselves, they buy it from China. So stuff gets brought from China to Djibouti and then has to be taken the 800 kilometers to Addis Ababa. Now the local road trucks were so inefficient that if you put 20 tons of diesel fuel in a road truck, on average, they'd used half of it by the time they got to Addis Ababa. Ethiopia now has a hydroelectric power plant and an electric railway. In Ethiopia, 14% of the cost of everything was transport. Imagine what would happen to your economy if you saved 10% of the price of everything. That is just an unbelievable economic stimulus and clearly pays for a new railway. Hence, I use that example. What's it trying to do? It's not really about the railway. That's about fixing the national economy. So, a lesson I learned in a rather dry part of Africa. Now, I worked for 8 years for London Underground. And London Underground was officially given this objective. Well, I say objective singular, that's the trouble. I deliberately wrote it on 2 lines like that, because it's 2 objectives. The first one is about saving time and maybe jobs and stuff like that. And gross margin is just a posh word for money. And this is where the problem starts. We've just given some railway managers 2 objectives which conflict with each other. I could do that, but I must take into account this. Now, 2 is okay. What I've been observing in the last 20 or 30 years is we've been making life more and more complicated. But which of these is more important? How many of them are we going to have? So I think you particularly begin to see more and more objectives for a railway. Money is easy. Okay. The next one I put here. Run these train services with safety as low as reasonably practical. What's that? And we get debates in that in Britain. I can say things because I don't have a safety responsibility. Economically, our railways are probably too safe in Britain. We're spending more money than is probably justified. Difficult political argument, but economically. So that's a trade-off. I think more recently, what I've seen, because railways generate lots of good things, for example, we reduce air pollution and reduce road congestion and provide jobs, all that kind of stuff. I see railway schemes being required to document all these. Let's pick an example. So I did geography at university. I've been interested in green things since, dear me, 45 years ago. That's a bit embarrassing. So we can say to a railway, we'd like you to be environmentally efficient. That's fine. And most good railways would be anyway. Now it's an objective. We have to have an environment manager. And the environment manager, therefore, has to go around all the other managers saying, What's your carbon footprint? How much electricity are you using? So we now land up with all these individual managers having to answer a lot of other questions. I'm a great believer in the environment. We just made everything a bit more complicated. And what I've seen in the last few years in Britain, very much looking at local social value. So we're going to build a railway in Wales. Can you make sure you employ local people? And, looking at American friends, buy America because it's local. It's another kind of constraint. So we've started making these railway things really quite complicated because actually the number of objectives we've got is, well, maybe it's getting out of hand. What to think about objectives? Well, you clearly have to have some. I think my observation would be it helps a great deal if you've got the money that goes with them. Because the other thing you see is, I want you to do this railway with this, and it, and I'm not going to give you enough money to do it. That's not very helpful. It would also be helpful if there was broad agreement so we could broadly do them over a period of time. And I don't want to be particularly political, but I think countries which have political parties who change the views entirely, this is not good for the railway. It would also be helpful if we were consistent. Now, I'm afraid in Britain, we've not been very consistent recently. We've got quite good at putting dense land uses near railway stations. We're quite good at that. But some of our taxation policies don't help. We're currently subsidising fuel for cars because it started in COVID, and I don't really want to politically get rid of that. So that's causing us some problems here. So what you need to do is keep checking that your railway fits with what's going on. So you might have government objectives, and I'm hoping we can get those into the railway as user requirements or system requirements, and please, therefore, as an output spec, not an input spec. I advise some rolling stock leasing companies, you do have to sometimes persuade them that they need to specify, how fast they'd like the train to go and how long it should be, not, for example, how many carriages it should have, because that's another trade-off. But the question I can't answer about objectives is who decides which is most important. So I'm going to share some things with you today, and I'm going to leave you with some questions, and that's the end of this first section, is a question I can't answer. So maybe we'll talk about that in the discussion. Now, I know you're systems engineers. I actually want to talk specifically about the timetabling process as it applies in Britain. But let's talk about railway timetabling generally. I think the idea is somebody identifies a thing, a problem or an opportunity, and you write out some requirements, and then you have some specific ideas which address those requirements, and then typically you find they don't work. For example, you decide someone's building a new town, so you should improve the railway services. We'll run an extra train from A to B, calling here, and then you find at a particular junction it doesn't work. We've got a hard constraint, so we go back and we change our ideas. We get a bit further, we get to the check stage, and you find, well, the planning margin's a bit narrow. Then we talk about punctuality, go back and do it again, and hopefully we do something. But things change. This isn't a problem. But then, maybe that's our opportunity. We've got traffic off the roads. But then, of course, people come along and build a whole load of houses, which is great. And then when you go through all these steps, well, the requirements have changed slightly. The idea kind of works. Now maybe the constraint doesn't work because, for example, we designed a train service to carry 200 people. We've now got 300 people. So to go back and do it again. And that doesn't work. And so maybe it doesn't actually take us 2 years to complete or implement. And the danger, and this is where Bruce and I started a conversation 6 months ago, is what happens when your objectives start changing as you go along? Because that's a bigger problem. Now, this will be easy in Britain, except we actually have 6 different timetabling processes which we apply to the same network. So you as systems engineers can straight away see why this might be a problem. The government specifies a whole lot of franchises, and sometimes we need to retime the trains. they'll come along and say, could you also do this? Either to an existing franchise or it might be a standalone thing. Then, of course, we have to change the timetable because we dig the track up. Then we have some entirely private companies, freight companies come along. Freight, of course, may want to carry one train next week, a 10-year contract. And then we need another way of dealing with when things really go wrong. I need to run a train right now. So we've got 6 different processes and only one network. And that comes to be a problem. This is a picture of London Marylebone Station, where hidden away on the right-hand side, you can see a diesel multiple unit. That's a government franchise service. There's a charter train in the middle. On the left-hand side is one of Network Rail's track maintenance things. It's all on the same track, all planned in 3 different processes. If you look at the long-term process, I'm afraid it does take us at least a year. It can take a lot longer. I've been working for a company called GoOp in Britain, a new startup, since 2014, and you're going to tell me this is now 11 years. It's quite depressing, really. 11 years. This is Grand Central. Grand Central took some time to get their services up and running, probably 5 years. Let's take a bit longer. But the normal process we try and go through to achieve our objectives, I mean, assuming you've got some money in a bank, we do a business case. Now, I've used the letter T here to talk about a timetable introduction date. And this is when you begin to see that systems engineering needs to take place, because about a year out, these numbers are in weeks, it is helpful if you can find somebody with a train. You may get official approval a year out. However, it takes at least a year to train a train driver. But you haven't even got a slot in the timetable yet. In Britain, you typically submit that a year in advance, and months go by whilst Network Rail try putting all these together. And that can take longer. We generally get something a bit like a timetable 4 months out. You try and get your lawyers to sort it out then. But we need to create seat reservations and create fares 3 weeks out, 3 months out. But we haven't got the trains yet. And the staff might not have finished in their training. We go through all this. It's been known for the regulator only to approve contracts 2 days before service starts, which is why so many people on the railways have, got grey or no hair. Everything can go wrong. It's a complicated process that we're trying to get our mind around, which involves various of the things I had in that diagram. Some demand stuff, some rolling stock and other things. So I thought I'd now share with you some dirty washing from various places in terms of some things that have gone wrong. Hopefully we might be able to work out how we can avoid this. I thought I'd start off from the other side of the world. I won't name either the Member of Parliament involved or the branch line, but a railway in Australia ordered a fleet of electric multiple units to replace some older stock which haven't got air conditioning. Now, you can kind of do without air conditioning in Britain most of the time. Yeah, not in Australia. So they worked out how many trains they want, and they placed an order for a fleet. From memory, it was like 50-something trains. After this had been signed off, the Minister of Transport realised that on their line, they're still going to have old trains with no air conditioning. So he ordered the railway to take the trains they'd ordered for this line and put them on his own line in his own constituency for political reasons. Except the line that was in his constituency was a different length and had a different service frequency, so they needed a different number of trains. So the fleet had to be split between 2 different lines, and that's just a complete disaster. So please, wherever you are, be prepared to tell politicians where to go, if necessary. Most of the things we managed to get wrong in Britain are a bit simpler than that. We just make mistakes. For example, our government asked London North East Railway to run a train every 2 hours to Middlesbrough. So Middlesbrough is a large town in North East England, which needs a bit of help, really. And it's fine. They worked out you'd need to build a siding. In 2022, in the early part of 2022, the train operator started organising themselves. They had a meeting with Network Rail, the infrastructure people, who went, oh, we haven't built that siding because we'd assumed we were going to build it, the year after next. So we got as far as we have one train a day to Middlesbrough, this is it. But we'd actually forgotten to build the siding to put it in. Those trains in general are still not running. So that's a bit incompetent, I think. It's a systems engineering problem. Now, that's very obvious. You can see that physically. When we look at timetabling stuff, okay, this is more where I'm coming from, but you can often see things going wrong immediately. So our government ordered a fleet of expensive bi-mode trains. Told Great Western there should be 4 trains now from London to Bristol, 50-minute intervals, straight for passengers, 2 to South Wales and 1 to Cheltenham. However, there are also freight trains on the line we're talking about here between Didcot and Swindon, and one section of this line, 12 miles long. And I thought I'd do some very quick sums. Now, I said some very quick sums. I did these in my head in about 30 seconds when I learned this. If you can run a train every 4 minutes, and you have to have trains at 15-minute intervals, the difference between the slow trains and the fast trains can't be more than 7 minutes, because that's 15 subtract 2 headways. However, if passenger trains take 6 minutes to do something, and freight trains take a minimum of 12, and if you've had them stationed and take 14, you can see immediately this can't work, because in my maths, 14 minutes subtract 6 minutes is greater than 7. Now, it took me about 30 seconds to work this out. After about 9 months, the railway industry had got its mind around this and then made some amendments. How did the government manage to specify something which I could work out wouldn't work in 30 seconds? Now, I'm my own worst enemy here. I actually train these civil servants, so you can blame me, but because that's a systems engineering problem. We've got an aspiration for train services. It's not possible. And I'm afraid we do need to say some things about high-speed 2 in Britain. I don't think this has been the perfect project yet. And there's various things one learns about it. For example, the original objective was find a route from London to Manchester, the best route at 400 kilometres per hour. As we're at the University of Birmingham, I'm delighted to say that the person who was asked to do this was a graduate of the master's course here, and she did what she was asked to. And she looked at 40 options and she found the best one. I'm not aware that anyone actually asked how would it be if we only did 360 kilometres an hour, at least not at that early stage. And clearly, since you can go around tighter corners and you can make your tunnels marginally smaller, that might have helped. What I did discover nearly 2 years later is that the government changed the objectives. So we're a large city in Britain called Stoke-on-Trent, broadly halfway between Birmingham and Manchester. Again, it's, I was carefully, economically sad. And the government realised that there'd be lots of economic benefits if this was somehow connected to high-speed 2. And there was a route that would have done that, except that they didn't actually tell the people doing the engineering planning. I mean, they didn't tell them for like several years, by which time we sort of missed that trick. Having said that, I did some work for the City Council, and the service plan for high-speed 2 now includes 1 train an hour going to Stoke on a branch. So at least they're sort of there. As you may be aware, about a year ago, we had another review of the project, and bits more got chopped off. I think you have to understand some other things here. So I'm not going to argue. At about £100 billion, HS2 is expensive. Not arguing with that. But the cost of the trunk section is the same, whether you build all of it or chop off all the branches. But if you chop off all the branches, you clearly chop off some of the benefits. So, for example, we don't get any direct links to Europe, so we can't compete against air. We couldn't at the time do anything between Birmingham and Manchester. I don't think one of our previous prime ministers and his advisor actually understood railway systems engineering at all. And I think that was the basis of some of these decisions. Once you've spent the big money on the big section, you want the maximum benefits you can from it. So that was a bit annoying, really, for those of us who understand anything about railway systems engineering. And they continue to do more about this. So, for example, the bit that we're currently building goes to somewhere north of Birmingham, and we have a main line with 4 tracks. We're building another 2. At the moment, they look likely to converge on a section of line with 2 tracks. Now, if you take all the trains from 6 tracks, it doesn't take systems engineering experts to notice this might be a problem putting them on two. They also didn't understand that it would have enabled us to get trains running on other parts of the network, even parts that look quite a long way away. And then they forgot the High-Speed 2 project had other benefits. So one of my many fingers in pies, I'm a service quality auditor for some of Britain's train operating companies. And this is Crewe Station. Now, Crewe is a very important junction. It's been an important junction since 1840. And you do begin to wonder whether some of these buildings have been there since 1840. They're in a shocking state. And HS2 was supposed to deal with that. But at the moment, we're not building HS2 to Crewe. At least we're not sure we are. So the railway's falling apart, which we could have forecast, couldn't we? But if you really want to understand how you can get this wrong, we're really good at this. If you build a high-speed line, you need trains that go quickly. And you're all engineers, I'm not, I'm very simple. Get this, high-speed line means trains going more quickly. We're also building it to a European loading gauge, so you could have bigger trains. Great. But because we have a restricted loading gauge for most of Britain, any train that starts on HS2 goes somewhere else has to be a small size. If you build all of HS2, it would have been worthwhile building trains to full European specification. We've had all that space. And if you've been to Britain, from America, you'll discover our trains are actually quite small. But once you're only going to build a little bit of the high-speed 2 network, there's no point building any big trains because you only want 4 of them. So you buy only small trains. Yeah, that's the first problem. We're now building trains to the British loading gauge on a line which is built to European loading gauge. So we've got this gap between the train and the platform. And then it gets worse. If you come to Britain, please travel between London and Scotland by train. Worthwhile journey. If you go out of Euston, you go to the Lake District after several hours. It's very picturesque. But we have tilt on our trains because the line's especially curvy. Now, I'm told by engineers who know much more about rolling stock than I do that fitting tilt equipment to trains is a bit complicated, and you really don't want to do it with high-speed trains. I mean, really high-speed trains. So we have an interesting situation now where the high-speed 2 trains that go to Scotland will be approximately 30 or 40 minutes quicker between London and Crewe than at the moment, and then 15 minutes slower between Crewe and Scotland because they won't be able to tilt when they go around the corners. How did we do this? It's because politicians don't get systems engineering. And then at a more local level, I've often wondered why we have tram systems in loads of cities. Everybody insists on buying their own. I'm really not convinced that people in Birmingham are that different from people in Lille in France or Duisburg in Germany, or people in America for that matter. Buy a small dedicated fleet. Why? So having a whole lot of bad examples, what are we going to think we ought to know? You're systems engineers, I'm a transport planner effectively, but done properly, it should be a systems discipline. Railways take a long time, so you might as well get everyone to agree. And I'm sorry, the V diagram is not about systems engineering for you guys, because you're only doing this bit. So Bruce pointed out in his introduction, I deal with a lot of stuff that's about here before the beginning. The other part of my job seems to deal with things that are here, where it's been constructed and doesn't work properly. There is, this really matters, not just for the engineering, hard engineering, but for the wider things we need to do. But what are we going to do if things change as we go along? I mean, what if things get a bit worse because they're more expensive? So what you get left with isn't worth doing at all. I do understand it takes a very brave politician actually to go, okay, we're not doing that, because you get an impetus. What if the benefit cost ratio isn't the right test? So I can tell you that the Jubilee line in London, that's the light grey one, was built to Docklands, opened in about 2000, with a benefit to cost ratio of 0.7 to 1. Now, I don't know anyone who lives in London who thinks that was a bad decision. It's enabled us to build up a whole area of the Docklands, do a whole lot of regeneration, absolutely worth doing. And actually, I think we've got a different problem. I did wonder, this is a slightly tongue-in-cheek question, I do wonder in Britain, when there's a lot of people in a small area, actually, if you build anything over a lifetime, economic activity moves round. People will be attracted to it. So I'm not saying you should deliberately build things in the wrong place, but I do wonder whether actually if you build anything half sensible, it'll probably be fine. Don't know. We'll perhaps talk about that later. And I want to encourage people to challenge standards. I'm going to talk quickly about some of these. Engineers design things professionally. I don't know many engineers who deliberately start out to design cheap, nasty things. But sometimes, of course, we have to tell them there's no money. And sometimes this systems engineering does work. So here's an example. This is King's Cross Station in London. There's a footbridge upstairs. Now, I'm told that the clearance between the bottom of the footbridge and the overhead wires, which are 25,000 volts, is actually fails any sensible, engineering standard. And one of the route directors for Network Rail was faced with a decision. It was £1 million to raise the bridge, which has got loads of lists associated with it. And he went, I'm not doing that. Now, I don't understand. Maybe someone on this call will. I gather, in the same way that you can get light reflective paint, you can get paint which discourages electrical transfers. So they painted the bottom of the bridge for £10,000. Didn't need to move the bridge. You go, yeah, now that's good systems engineering. Someone's actually thought outside the box. So sometimes maybe we should challenge standards downwards. Now, we have some group standards in Britain for new infrastructure. These are what they should be for new platforms. And we're not really supposed to have tracks with platforms on both sides. So here's an example of one. We're allowed to keep the ones we've already got. It's called grandfather rights. This is a local station in South London, and we have third rail in this area. And when I first moved to South London, it was great because you could get off a train here, you could cross the platform and get in one here. And we had slam door trains. We now have electric door trains, and this has been prevented because, well, can't look both ways at once. And we have people who drop stuff on the track, potentially. So we require people to run down a flight of stairs and run up another flight of stairs, the risk of which is probably bigger than that. So I've tried challenging that with Network Rail as well. We've replaced one risk with another one. Sometimes, however, I hope as systems engineers, we challenge standards upwards. So I'm not a permanent way engineer, but I do understand that point work's expensive. Now, this is, I think, Apeldoorn in the Netherlands, and double slip like that's just horrendous for maintenance. So what we've often done in Britain to save money, we put in what I call cheap, nasty pairs of points, which are quite short, very severe angle of divergence, and you can crane them in. It's great. But of course, you can diverge at 20 or 30 kilometers an hour, and they probably lose you half a train path every time you do it. So one of the arguments, another arguments I've had with Network Rail is when they're told to save money, they do this. Don't seem to understand they lose line capacity. Sorry, we'd like the more complicated sets of points that we can diverge at 100 kilometers. I know it's going to take you a whole weekend to install it. Otherwise, you're just going to lose half a train path per hour forever. And the cost of that is probably, the value of that, greater than the cost in installation. So it is worth challenging the things we've got. So what am I supposed to conclude? Well, I hope you're going to give me some conclusions, because I'm still a bit mixed up about all of this. I'm sure we should have a proper process. I'm very sure about that. I'm also aware we have multiple objectives, but I'm not quite sure who should determine A, what they are, and B, which is more important than the others. I am sure that railways are systems, and we need to explain to stakeholders who know less about railways than we do as to why if you change this, you get a different answer. And that might mean challenging the standards. I think it's also worth remembering what we were trying to do when we started off. One of our problems, I think, in Britain with high speed 2 is the name. High speed 2. It's not about high speed. We were short of capacity. I do wonder whether all our mistakes started happening when we had the wrong name. And I think it's just worthwhile that, if we're going to be in this for the long haul, it is worth doing a whole load of kind of community and stakeholder stuff quite early on, because we really can't deal with big changes to a project when we're halfway through, I think. But I've now got to my point where I don't really know what else to conclude. So I was hoping, Chairman, that we'd have some discussion and people can tell me where I got it all wrong, or maybe give some answers to some of these questions.
Is that the end?
That's
Excellent. I'm out of shot because I'm sitting at my computer, ready to pass on any questions from online. But before we do that, let's give opportunity to ask questions to people in the room. Does anyone want to ask any questions in the room? Okay. Matt, let me give you the microphone so that they can hear you in Chicago and Canada and everywhere.
Thanks, Nigel. That was really interesting and perhaps a good description of the problem.